In this video, we're going to work on another example on hypothesis testing of the population mean, and we're going to use data file administrator. So here's the question number 33. So in this question, we want to see if the salary of the administrators, school administrators in the state of Ohio is different from the national average. So this is the keyword here. So we want to see if it's equal or not, all right? Which actually indicates a two-tailed type of test. So the question asks to formulate the set of hypotheses, and basically, again, here we have the statement for the alternative hypothesis, because here's again the keyword here is differs from the national mean of 90,000. And then the question asks us to find the p-value, and then based on the p-value, make a conclusion. So here I have data file administrator. All right. So here we have the sample. I'm gonna paste this, which shows us the test statistic. So this is, like I said, a two-tailed type of test. We want to see if the population mean of administrators' salary in Ohio is different. So this is our research question. This is what we want to see. If it's different from the national average of 90,000. So for this is going to be our hypothesis. So I'm going to write it down. Null hypothesis, if mu being the average of salary, like average salary of school administrators in the state of Ohio, mu is equal to 90,000, and 90,000 is the national average. And alternative hypothesis, if it's not equal to 90,000. So that is the null hypothesis. So alpha in this question is 5%. So I'm gonna come back here. Level of significance. So step one, set up the null and alternative hypothesis. Step two, determine alpha or level of significance. The question actually gave us the confidence level of 95% or alpha of 5%. It's actually level of significance alpha 5%. So, and then I need to find these test statistic in order to be able to find the p-value here. So for that, I need to find these. I need to find the sample mean. I have the hypothetical value of 90,000. I need to find standard error, which is standard deviation divided by square root of sample size. So sample mean x bar, sample or standard deviation of sample, standard deviation S, and then hypothetical value. I have mu 0, and then maybe if I put it here, standard deviation sample size, and then standard error. So standard error, and then we can get the test statistic T, a hypothetical value, and then we can find p-value. Again, I'm going to find p-value lower tailed, upper tailed, and two-tailed tests. We don't have to. I mean, we can just apply the formula, but still for the two-tailed, we need to use the p-value one-tailed, one-tailed basically, either both of them, lower tail and upper tail. We need to find the minimum value. So, and because of that, it's always safer if you do the whole process: lower tail, upper tail, and two-tailed. And then we make the conclusion. So this is basically what we need to do. Just to show you the formula, here I have the formula. So sample mean is going to be average of the salaries, average, standard deviation stdev.s of the numbers, Control Shift down, sample size, count, or count A of the numbers, 25 of them, standard error stdev.s of the sample. Sorry, standard error is S divided by standard deviation divided by square root of n. So S divided by SQRT of 25. So that's the standard error. And now test statistic is X parenthesis, X bar, sample mean, minus hypothetical value, which is 90,000, or let me just put it here, 90,000. And let me then just take this from here, put it here actually. All right, so hypothetical value 90,000. Now the test statistic is going to be X bar parenthesis, X bar sample mean minus hypothetical value divided by standard error. So now I have the test statistic minus 2.14, which is to the left side of the distribution. So for p-value two-tailed, I need to take the p-value lower-tailed and multiply it by 2, or we can just take 2 times minimum of these two. Right? So now lower-tailed is going to be t.distribution, t.dist of test statistic, degrees of freedom n-1, sample size -1, and true for cumulative. So that's the p-value lower tail, and we already have a p-value two-tailed. It's going to be less than alpha 5%. So p-value upper tail is going to be 1 minus p-value lower tail. But at the end of the day, this is what we need. This is a two-tailed type of test, two-tailed test. And because of that, we just look at the p-value two-tailed and make our conclusion based on these p-value two-tailed. So since p-value is less than p-value, I'm referring to p-value two-tailed. Again, this is a two-tailed test, is less than alpha, and alpha is 5%. We can go ahead and reject the null hypothesis. So in conclusion, if p-value is less than alpha, we go ahead and reject the null hypothesis. So we reject the null hypothesis and conclude with 95% confidence that, so if we reject the null hypothesis, we're going to take this. We're going to take the alternative hypothesis. So when we take this one, our conclusion is that the average salary in the state of Ohio for administrators of school is really different from, is statistically different from 90,000 or the national average. We're confident that the average salary of school administrators in Ohio is different from, or statistically different from, the national average of $90,000. All right, so this is our conclusion.